Okay, in my next question, is 18 a square? No. So that's a big hint that you're going to look for a common factor. So, like we just did at the beginning of class. 18 and 50 have a common factor of a 2. Both terms also have x common. One has a power of 3, one has a power of 1, so I take out a power of 1. Both terms have a y. One's a y to the third, one's a y to the 1, so I take out a y to the 1. And I divide this in. 2 into 18 goes 9 times. X from x to the third is x to the second. Y from y to the third, y to the second. Minus 2 into 50 is 25. X into x would cancel and y into y would cancel. Look what's left in the parentheses. Is what's left in the parentheses a difference of squares? Is 9 a square?
Yes.
I have even powers, so their squares is 25 a square. Got my minus? Okay, so that means we're going to go again. So 9x squared y breaks to 3xy times 3xy. 25 is 5 times 5. One gets a plus, one gets a minus. Question on that one? Is x to the fourth minus 1 a difference of squares?
Yes.
Yes. Okay. Is there a common factor there before I do it? No, not other than 1. So x to the fourth goes to x squared times x squared. 1 breaks to 1 times 1. 1 gets a plus, 1 gets a minus. And you're thinking, well, that was an easy one. Why did you put this at the end? Maybe you were thinking that, maybe you weren't. This is why. One of the most difficult parts about factoring, when we get all through the whole thing, is knowing if you're finished or not. And we're not finished on this question. Okay, we're not finished. And that's because we have created, by doing that, another difference of squares. Right there. So we got to factor further. The first one does not factor because it's not a difference. I'm going to give you a hint here in a second. So my second parentheses that I have underlined will go further. It's going to go to x times x for my x squared. 1 is 1 times 1. 1 gets a plus, 1 gets a minus. Now I'm done. And here's your big hint. When is that going to happen? Ding, 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 ding. What's my power in the beginning of the question? 4. When you've got a power of 4, it's going to break to x squared and x squared, which gives you a really good possibility of going again. Now, if you start off with x squared, that's not going to happen. I mean, you're going to go xx. So when you see a power of 4, that's your big hint to think, well, I might be able to go further on this one. Okay? And then I'm done. I should have said that. Done on that one. Okay, 2 more. This one's a trick question. Okay? Because most people avoid looking for it. They look at it and they say all squares and they start factoring. But there is a common factor there. They both have an x. So that should come out first. One has an x to the 12th, one has an x squared. So I'm going to take out x squared. And then I'll divide. 16 will come down. X to the second from x to the 12th. Divide that in, subtract it out. That leaves me x to the 10th. 81 comes down, and x squared cancel. When I took that out, I got a difference of squares, so I'm going to factor again. So 16x to the 10th will break to 4x to the 5th times 4x to the 5th. 81, 9 times 9. 1 gets a plus and 1 gets a minus. Look at that second set of parentheses there. Is 4x to the 5th minus 9 a difference of squares?
No.
What's keeping it?
The 5.
Perfect. Because the 4 is a square, the 9 is a square, I got a minus, but I have a power of 5. So you're done. Very good. Okay, last one. Common factor. We know there's a common factor because we don't have squares here. 5's not a square, 80 is not a square, so that's your big, big hint that something's going to come out. So I'm going to take out a common factor of a 5. So 5 divided into 5 is 1. Has to be there. 5 divided into 80 is 16. My x to the 4th comes down. It looks like a very good 4 there. Okay. Is 1 minus 16x to the 4th a difference of squares? Yes, it is. We all said with such confidence. Not. So I factor. 1, the first term, breaks to 1 times 1. 16x to the 4th is going to go to 4x squared times 4x squared. 1 gets a plus, 1 gets a minus. Can that go again?
Yes.
Yes, all squares. Notice that I only look at the ones with the minus. Because to be a difference of squares, it has to be a minus. So I don't even look at the plus one. So my 5 comes down. My 1 plus x, 4x to the 2nd comes down. But this one at the end goes again. I don't quite have enough room there. 1 times 1, 2x times 2x. Don't need you. Plus, stop it. Plus and minus. We'll make it look somewhat decent. And then I'm done. Okay? Now, even though we know that everything we're doing in goal 2 is difference of squares. Okay, we're not doing trinomials, we're not doing grouping, which you'll know what those mean later. Right now, it's just squares, nothing else. I still want you to think 3 steps, okay? And I'll reiterate this several times throughout all of goal 4. So 1, is there a common factor? That's what CF stands for. Look for that. Because if there's a common factor, it needs to come out. 2, factor into your 2 parentheses. So factor your difference of squares. And then 3, can I factor again? And our big hint was power of 4. It could be other powers, but it's usually a power of 4 for what we're doing. So get in the habit of asking yourself those 3 questions, because we're going to carry that out through all our factoring, those 3 questions. Okay? That's all I have.